Hey everyone, I'm Sanjana. Today I'm going to walk you through chain of thought prompting. First, we'll talk about some techniques behind chain of thought prompting, why you might want to be using it, and then we'll jump into a notebook where we'll use Phoenix prompts and experiments to actually employ some of these techniques. We'll run some prompts against some data sets, we'll do some evaluations on these experiments, and hopefully you'll walk away from this understanding how chain of thought prompting can be useful in your own applications. So the idea behind all of this is it's a prompting technique that's going to allow you to enable complex reasoning through intermediate reasoning steps. So instead of just having your model output an answer, we actually specify within the prompt itself to reason. And those are those intermediate reasoning steps that I mentioned. The goal here is to improve your accuracy. You can imagine some really common use cases here are logic problems or multi-step reasoning problems. Because of that, the data set I'm going to be using today is math word problems. You'll kind of recognize some of these from like a classic high school algebra textbook, but this is a really good demo for us to be using. So let's jump down to this diagram I have over here. I've paraphrased some prompts. You'll see them more robust and written out in the notebook itself, but our baseline prompt is just output an answer to a word problem. And I have 3 different versions here of chain of thought prompting. So let's start with the first one that just says chain of thought prompting over here. The main idea here is encouraging reasoning, as I mentioned before. So instead of just outputting an answer, we also specify to first think through the problem, output some reasoning, and then determine an answer. This is kind of like showing your work and thinking, and specifying to just take a moment before answering. The next step here is self-consistency chain of thought, where we encourage reasoning and multiple computations. So we output an answer to a word problem, we think through the problem, show reasoning, and then we do this several times and output the majority answer. This kind of eliminates a little bit of the randomness with LLMs and just gives you a more concrete, solid answer at the end of it. And then finally, the last technique we'll be looking at is few-shot chain of thought prompting, where we encourage reasoning and provide examples. So we output an answer to a word problem, we think through the problem, and then when we tell the model to think, we also offer some reference examples for how to think step by step. And then I have a variable here, examples, which we'll pull from a training data set and put in there. So these are our 3 ideas that we're going to walk through today. Now let's go to our notebook and actually work with some of these. So now we're in our notebook, and I've done some setup here. I'll walk you through that. I've installed Arise Phoenix version 8 or greater, which has our prompt sub, which we'll be using today, as well as datasets and OpenAI instrumentation. We'll be using OpenAI models to run our prompts today. I've connected to my Phoenix Cloud instance. You can also choose to self-host. It's up to you. And then with that, I've also entered my Phoenix API key and my OpenAI API keys. Next, we'll load our dataset into Phoenix. I've imported this dataset from Hugging Face as a data frame, and then we turn that into a Phoenix dataset over here. What this is doing is allowing us to have a centralized place where we can jump back to our data set, see our data points, run experiments, do comparisons, and all of that. And I've also went ahead and instrumented my application. So if we jump over to Phoenix and we refresh, we see our word problems data set. So we have our inputs, which are our math problems, and then we have outputs, which are just an integer, and experiments are where we're going to see our different prompting technique results. So let's go back and get started with that. Phoenix is very intuitive in that it lets you store, tag, and version your prompts all in code or in the UI itself. We're going to be doing code, but I'll also be showing you how it looks like in Phoenix. We're using OpenAI, so we're going to import this param space from the OpenAI library. And what this does is it lets you specify the model. We set our temperature to 0 here, as well as the message. The message is this very basic prompt that we showed earlier, where it's just you're an evaluator who outputs the answer to a word problem. I've also included some specification here so that it only outputs an integer. And then it also takes in this variable here, problem, from our data set. So for every row, it's going to grab the problem, the input variable there. And then we're going to use the Phoenix client to actually create this prompt. So our prompt identifier, I'm going to call this word problems. And then our prompt description is just our basic prompt for computing answers to a word problem. And then we pass in our parameters that we just defined. So if I run this and jump back to Phoenix, under my prompts tab, I now have this word problems prompt where we can see exactly that system message that we specified, the variable that it takes in, other model configurations. Phoenix stores more than just the message for the prompt itself, and just our simple version that we've started with. As we iterate on this prompt, you'll see this version history build. So jumping back now, let's actually use this prompt. So what we do over here is that we define a task that runs on every single row of our data set, an evaluation that does the same thing, as well as an experiment. So what our prompt does is it takes in the prompt that we specified above, as well as the input variable, which is word problem from our data set, and it returns a answer that the model had outputted. And in our evaluate response, we take that answer and we compare it to the output column from our data set, because our data set that we grabbed from Hugging Face already has those integer answers there, so we can kind of treat it like ground truth labels. And when we use this run experiment function over here, we specify that data set, the task, the evaluator that we just talked about, as well as some metadata to name this. So let's go ahead and run this. and our experiment is going. So now that our experiment's finished running, let's jump back to Phoenix to actually see some of the details here. So this is our datasets tab from earlier where we had our dataset imported. But if we look at experiments now, we can now see that the outcome of this baseline prompt was about 78%. If we click into that, we can see, which ones were successful and which ones weren't. If it was correct, there is a 1 outputted, and if it was wrong, you can see a 0. You can click into this to see, exactly why it was wrong. But now that we've kind of seen the process of creating a prompt, defining a task, an evaluator, and running an experiment, we can repeat the same process with our improved prompt. And let's do exactly that. So next we have zero-shot chain of thought prompting, which is that first iteration that we saw in the diagram, where we specifically say you must always think through the problem logically before providing an answer. First, show some of your reasoning, and then we have the same specifications for how to output the answer and the formatting so we can run our evaluations a little bit easier. And we use the param space function again from OpenAI to specify the model, messages. We put in this problem variable, and then we use our Phoenix client to then create this prompt. This Phoenix client is specifically Python right now because that's what we're using, but this is also available in TypeScript. So we run that, and if we go back to Phoenix now, and we go to our prompts tab, click on word problems, we can now see that we have a second version of our prompt. This is exactly what we defined in the code, but if we jump back, we can see how our version history is changing. Let's go ahead and redefine our task and our evaluation. This is doing the exact same thing, but it's just doing a little bit of formatting because of how the reasoning is going to be outputted as well. Let's go ahead and run this. We're running our experiment. Let that run. So at this point, our experiment's finished running. Let's jump back to Phoenix to see our results. So we can see a slight increase in performance here with our zero-shot chain of thought prompt, and we can do a side-by-side comparison between the two. Let's click into one of these traces to see what the model had done with that extra reasoning step now. So we can view our trace, and because we enabled instrumentation, we can actually see what was going on under the hood here. So this is the explanation that the model had outputted for this specific problem here about parking spaces, and the output was 760, and we can see that that was deemed to be correct. So now let's continue onward with self-consistency. So this is our self-consistency prompt here. This is a little bit different than the other two. So what we have here are these steps that we specify in the prompt itself. So we say, solve the problem multiple times independently, thinking through the solution carefully each time. So that's our reasoning. And show some of your reasoning for each independent attempt. Identify the integer answer that appears most frequently. So we're pulling out the most common answer that we have. And we specify some formatting. So let's run this. If we were to jump back to Phoenix, we'd see that third version of our prompt now. And we do the same process here where we use this function to actually format our prompt correctly, take in the input variable. This is our task. And then we have our evaluation as before, as well as our experiment. So let's run our next one. Once again, our experiment has finished running. Let's go back to Phoenix. And if we refresh this, we can see a slight improvement as well, which is great. Click into this. Let's do a side-by-side comparison with zero-shot COT. Already off the bat, what's interesting here is you can see that this one was correct for zero-shot COT, but with self-consistency, this was wrong. So we'll see those slight performance differences, even though self-consistency COT overall performed better. Let's click into a trace. And if we look at that, we can see the different attempts that were taken here. So after doing all of that, the most frequent answer is 1872, and that was outputted there. All of these traces are going to have a similar structure where we have 3 attempts and the answer that appears the most frequently, which is really cool to see. So now let's go ahead and look at our final prompting version, which is few-shot chain of thought prompting. So we're going to go ahead and use this map word problems dataset from Hugging Face. This is slightly different than our original dataset because this one's going to have some explanations so we can actually show step-by-step reasoning. We're going to sample 5 examples from that so we can see we have our word problem, an explanation, and an answer. And we're going to take these few-shot examples that we have and put this directly into our prompt. So we can see our prompt is slightly different here now, where we have our part where we think through the problem, provide an answer to the word problem, some formatting specifications, and then this is the few-shot part where we say, here are some examples of word problems, step-by-step explanations, and solutions to guide your reasoning. And then we insert this variable examples over here. So we do the same thing where we do the param space specification for the parameters, and then we create our prompt. I just ran that. So if we go to Phoenix, go to prompts, word problems, versions, we see our most recent version here is few-shot, and we can actually see how those examples were inserted right into the prompt over here, which is cool. So now if we go back, let's do our same process, task, evaluation, running the experiment. You probably know exactly what this is now. So now our experiment has finished running. Let's jump back to Phoenix. We can see that we had an 84% success rate here, similar to self-consistency. But of course, if you go ahead and run this yourself, you're probably going to get different results because of how these models work. Like before, we can just click into this, do all the comparisons we want, and hopefully you've walked away with this understanding the different flavors of COT prompting and how you can use that in your applications and leverage experiments and prompts in Phoenix to iterate, test however you want. We'll link the notebook below for you to try this out yourself. And if you have any questions, feel free to jump into our community Slack and ask away. I'll also have that link below. Thanks.